Now, I'm going to be entering the topic circular motion. Now, like I said before, we have different types of motion, and have circular, we have random, we have oscillatory, linear, and all that. Now, let our focus just be on circular motion. Now, under circular motion, we are just talking about motion around an orbit. So, if we are talking about circular motion, we are talking about motion around an orbit. So, let's say you are moving from point A to point B. You possess circular motion, or you exhibit circular motion. So, let's do something like this. Now, call here S. Then, from here to here, we'll call here arrow. Then, we'll call here theta. Aha. So, firstly, I know that you already know velocity, and velocity is equal to displacement over time. Now, the unit of velocity is meter per seconds. Before, we talked about this before. Now, in circular motion, we're talking about velocity now. We're talking about another type of velocity. So anything that has to relate to circular motion now, we're talking about angular velocity, because we're talking about angles. You understand? So circular motion is more related to angular. Talking about angular velocity. We're also talking about this other side that we're talking about displacement. Now talking about angular displacement, and we're dividing it by time. So now angular velocity is represented as omega. So this angular velocity now is omega. Omega is equal to angular displacement represented as theta. Then time is represented as t. So you take note that omega equal to theta. This is taken as theta over t. Theta. So let me write it again. Omega equal to theta over t. So now you take note that when a body is going around a circle, you take note that angle at a point is 360 degrees. So we can say as the body is going around a circle, theta is equal to 360 degrees. And this theta that is 360 degrees is also 2 pi. You know, 2 pi. Talking about 2 pi arrow. Now, it's 2 pi radians. 2 pi radians. So if they ask what's the unit of angular displacement, the unit of angular displacement is radians. So omega will now be equal to 2, theta equal to theta over t, which is equal to 2 pi. Now, but for this 2 pi to work, we're also going to take t to be equal to big T. And what does this big T represent? The big T represents period. So you now take note that omega is equal to 2 pi over period. So you take note omega is equal to 2 pi over period. Now, we're also going to go back again. I want to tell you what period is all about. I was talking about period just now. So what's period all about? Period is defined as the time taken to complete one revolution. Period is defined as the time taken to complete one revolution. So the time it takes you to complete one revolution, because you know we're talking about circular motion now, talking about revolution, moving around an orbit. So the time it takes to complete one revolution is called what? Period. So we can say period, which is t, is equal to t over n, because we're saying the time taken to complete one revolution. So this is our time taking. Then this n represents the number of what? Revolution. So that's t over n. So t equal to t over n. And the unit of period is seconds. So the unit of period is seconds. Take note of that. So period is time taken to complete one revolution, and the unit of period is seconds. Take note of that. Now, I'm not just talking about period now. I'm also talking about another aspect that is very related to period, which is called frequency. Now, frequency is defined as the number of revolution per unit time. Number of revolution per unit time. So meaning that we're talking about f. Period is frequency represented as f. So f is equal to n over t. So we already said T equal to T over N before, and now I'm saying F equal to N over T. Now the unit of frequency is hertz. The unit of frequency is hertz, which is taken as Hz. Unit of frequency is hertz, which is taken as Hz. So now let's observe something here. If T equal to T over N, observe this, if T equal to T over N and F equal to N over T. Now, what if we now say 1 over T? 1 over T is going to give us N over T, because we just turn it upside down. So I will now have 1 over T equal to N over T. And what was N over T here? N over T is equal to F. So that means we can say that frequency is equal to 1 over period, and period is equal to 1 over frequency. So you take note that frequency and period are inversely proportional to each other. So we can take note that if frequency is inversely proportional to period and period is inversely proportional to what? Frequency. Take note of this information. So from here now we said omega is equal to theta over t, which is equal to 2 pi over period, which is already going to be 2 pi into 1 over period. Remember, 2 pi times 1 is 2 pi. So we have 2 pi over period. Now if we have this, we can now say that 2 pi, what's 1 over period? 1 over period is f. So we can say omega is equal to 2 pi f. So take note that omega is either equal to 2 pi f, omega is equal to 2 pi over period. All right. Now from what we've got in now, we're going to get omega 2 pi over 2 pi f. Omega is also equal to 2 pi over period. Now this is our circle. Now we're going to come back to this circle. This is what we have here, and what we have now. If we have this, we can try it out and see what we'll get. So from here we have S, we have arrow. Let me just put here as arrow. We have theta. So now I'm going to say that theta equal to S over arrow. You know, theta is our angular displacement. Then S is the distance. Distance is sweeps. Then arrow is the radius. Now if we are relating this, we can cross multiply. You can say theta arrow or arrow theta equal to S. So let me just put that S equal to arrow theta. Now, you still remember that velocity is displacement over time, right? Velocity is equal to displacement, which is S over t. Now, if we have this, we can also make displacement subject of formula. So we have S equal to Vt. Now in physics, we always relate formula. So we can say S equal to S. And if S equal to S, we can say arrow theta is equal to Vt. So from here, we can say that let's make V subject of formula divided by T. From here, we have T here 1, T here 1. So we have V equal to arrow theta over T. Now from here, we can say that V equal to arrow times theta over T. Now we already know that theta over T is omega. So we can come here and say arrow times omega. So we can say that V equal to omega arrow. This is the formula I'll be looking for. So V equal to omega arrow. Now take note of this, that V, which we have here now, is the normal velocity you know. But this velocity you know now, we can call it two things. It can be called tangential velocity, and it can also be called linear speed. This V you are seeing here can also be called tangential velocity or linear speed. And the unit of V here is meter per second. While the omega you have here is called angular velocity. And the unit of angular velocity is radian per seconds. Then this arrow is radius, and this radius is taken as meters. The unit of radius is meters. So you take note that V equal to omega arrow. Now another thing now I'm going to say is that if V equal to omega arrow, we can also say we have what we call centripetal acceleration. And centripetal acceleration. Now, before I even talk about centripetal acceleration, I'm going to state something very clear. When you're talking about circular motion now, let's say this is a circle now. There are two forces that act on a circle, a body moving in a circular path. We have one force which is called the centripetal force, which makes the body to be pulled towards the center, while we have the centrifugal force which tends to pull the body out. So we have the pushing towards the center, we have the pulling force, the force that pulls you towards the center, and the one that pushes you away from the center. Now the one that pushes you away is known as centrifugal force, while the one that pulls you is known as centripetal force. And centrifugal force that pulls you away, the one that push you inside. Now the next thing you also think about is they tend to make the body to be in equilibrium, to be in a circle, so it doesn't drift away and still maintain itself while moving on a circular path. So the centripetal acceleration, AC. AC has a general formula which is v squared over r. The general formula for AC is equal to v squared over r. Now, just take note of this. Now, if it's v squared over r, how do we go about it now? How do we relate this with the formulas we already know? Now, we already know that v is omega r. So if v is omega r, just come here and write omega r squared over r. So now we're having AC to be equal to omega square r. You know there's still one arrow here. It's supposed to be omega r, omega square r square. But now I'm saying omega square r times r over r. Because I want this arrow to cancel out. So arrow here 1, arrow here 1. So what are we having left? AC equal to omega square r. Now, for me, we can say that centripetal acceleration is omega square r. Now, if centripetal acceleration is omega square r, we can now state that if we have AC to be omega square r, we can have two formulas for AC. So AC can be either equal to v squared over r or omega square r. Then we also have another aspect which is called FC, which is centripetal force. You know that force is mass times acceleration, right? So if force is mass times acceleration, we can say this is MAC, which is M times AC, which we already have before, to be v squared over r, or M times omega square what? R. So we can have FC and we can have AC. FC, which is mv square over r, or FC, which is equal to m omega square what? R. So any of these formulas can work and give us the best answer we need.